Here's problem number 3 in sample test 2. A roller coaster car has a mass of 600 kilograms when fully loaded with passengers. At the bottom of a circular dip of radius 40 meters, as shown, the car has a speed of 16 meters per second. Draw a free body diagram for the car. Alright, let's just draw it right on our diagram here. We're going to have weight, so we have weight equal to mg pulling down on the car. And we have a normal force of the track on the car pushing up. And as a result of these two forces, there is an acceleration towards the center of the circle equal to v squared over r. That is our free body diagram. The velocity is not a force, so that doesn't contribute to the free body diagram. So that is strictly our free body diagram right there. Okay, part B. What is the resultant net force on the car? If we look at this free body diagram, we would see that the summation of the forces in the y direction is equal to mass times acceleration, and that's equal to the net force in the direction of acceleration, which would be normal force minus the weight. Strictly speaking, the mass times the acceleration, v squared over r, is equal to normal force minus mg. Nice to know. As we look at this, the net force is the mass times acceleration. It's also equal to the summation of all the other forces added together. But this is strictly our net force, our resultant force. So that's all we're looking for in this particular case. So our net force is equal to mass times v squared over r, which would be 600 times 16 meters per second squared over 40 meters. And what is that? (3,840 newtons). So that is our answer to part B. Part C was the magnitude of the force of the track on the car at the bottom of the dip. Now we want N, and we're going to use this formula. So we know that N should equal ma plus the weight, and that's going to equal mass times velocity squared over r plus mg. We already figured out mass times velocity squared over r. That's 3,840 newtons. Plus mg will be 600 times 9.8. So this would be that. (9,720 newtons). So that is the normal force of the track on the car. That's the magnitude of the force on the car, and it would be, in this case, going upward towards the center of the circle. Answer.